Thank you all for coming. Title's fairly self-explanatory. I hope there won't be too much overlap with what Bruce said this morning. Just a little plan of the talk, very quick. Firstly, a bit of motivation to explain why I'm giving the talk I'm giving. Secondly, a bit of a disclaimer, because I know what a diverse group you are, and I've heard from you all this morning about your various research interests, which I think is great. The bulk of the talk is going to be 7 deadly sins. Unfortunately, while listening to Bruce's talk, I thought of an 8th deadly sin, which slightly spoils the kind of literary conceit, but never mind. You probably won't have noticed it happening, but in your training at university, you will have had the research methods that you were taught, depending on where you come from, situated for you in the context of your own research field. So if yours is a field where they use a lot of qualitative research, do a lot of ethnography, you will have read good examples of ethnography from your research field. You will have been told how that fits together with more statistical approaches and so on and so forth. That all will have been sort of laid out for you, and you'll have a kind of mental map. One of the things I'm going to try and do in this talk is to sort of re-examine your mental maps a bit and see where you should find a space for simulation in it, because it's not like all the stuff you've done before, probably, and it's not necessarily sitting terribly comfortably with some disciplines rather than others. It sits a bit better with economics, which is quite formalistic, and not quite so well with anthropology, which is a bit more qualitative, and so on and so forth. And the idea here is for integrated research, that you should know not just about ABM and how to do it, but also about how it fits into the wider context of the kind of stuff you do, whether that's a PhD or your subject of origin or applied research in a particular domain. A couple of the things I'm going to say I think really ought to be statements of the obvious, but my experience is that sometimes they're not statements of the obvious. And at risk of boring some of you, I will make sure that the rest of you know these things. This talk is basically inductive. I have worked from reviewing papers in journals, supervising PhD students, giving advice to people starting out, to look at the kinds of things that people tend to get wrong when they start out in simulation. So although the list may sound a bit arbitrary, it is actually based on quite a lot of experience. I'm not just making these things up as potential problems. And also a chance for you to reflect on how this fits in with what you're currently up to. How to get a simulation accepted as part of a PhD, how to move from a PhD based on case study research to a nice postdoc in simulation if that's what you want to do, how to persuade your colleagues that simulation is a good thing to be doing in some particular aspect of your work, depending on where you are, because I know some of you are at different positions. This talk is kind of a corrective to the fact that this week will be very much focused on ABM, what ABM believes, how the technique works, and making sure that you keep in mind the context. And sometimes that's a kind of a research methods context, sometimes that's a kind of strategy context, making sure that your supervisor doesn't have a hissy fit when you try and introduce a model into your PhD. Sometimes it's a kind of career context, what am I going to do next, and how is this going to fit in with what I've done up until now. And as I say, this is inductively based. I have drawn on my own reasonable experience to come up with this list of don'ts. As with Bruce this morning, I'm going to try not to talk for more than an hour. I'd actually like to talk for a bit less than an hour. I know you're a very mixed group. I'm going to start from where I am. Where I am is sort of economic sociology, so I'm going to talk about the research methods that are common in those areas. I know, for example, there's at least one archaeologist here, and there are all sorts of interesting stuff about how we build simulations based on archaeological evidence. There may be people here who are very qualitative, or people who come from particular disciplines with particular methods. Experimentalists, for example, would be a whole other group of people to talk to about simulation. So what I'm going to do is I'm going to try and leave plenty of time for people who say, well, this is all, you know, what is all this? I do randomised control trials. Talk to me about randomised control trials. Or I do social networks. Nothing you've said has got anything to do with social networks. I'm going to try and leave plenty of time for that connection, because if I try and talk to all of you about everything, you'll probably spend most of the time bored or confused, because there are, you know, significant numbers of different research methods across the social scientists, across the social sciences. And the other thing that's interesting about this actually is that there are areas where there aren't pat answers. Trying to compare spatial distributions in simulation, for example, is not trivial. We're still working on that. So depending on what you're interested in, I may not just be able to give you a snap answer anyway. It doesn't mean the question isn't very interesting. This is really basic stuff, and I hope I'm not telling anybody stuff they don't know already. Examples of typical research questions. How much does gender affect educational success? Does it matter being male or female to how long you are likely to stay in education and what grades you are likely to do? That's That's a straight down the line statistical question, probably based on survey data, quite likely based on national representative government survey data. How is racism done in the police force? People might say that the police are racist, but how does racism actually play out, for example, in a particular area of the police force? That's an obvious ethnographic study. You go, you watch, you listen, you talk, you try and find out what it's like to be in that particular police station or that particular area. How do people respond to instructions from authority figures? Well, you'll recognise that piece of research as the Milgram experiments done using relatively naturalistic experiments rather than the economic style of press button A or press button B. You dress people up as the men in white coats and then see what happens. How have representations of the Irish in the media changed over the last 150 years? A content analysis type question. You look at a sample of articles, you look at the descriptions that are used, you look at the way that images are presented, the sort of thing you might do in media studies or in the more qualitative end of sociology. That's just 4 examples. I haven't talked about social network type designs, I haven't talked about time series analysis, I haven't talked about randomised control trials, I haven't talked about gaming. You get a group of people together and they pretend to be the crew of a submarine, and then you look at how decisions are made under stress. So you can see why I'm not going to be able to go through all the different research methods and how simulation fits with each one of them, because even a shortlist already has too many items on it to discuss. So I'm going to focus on the big 2 in sociology, and we'll kind of take it from there. So it's going to be surveys and statistics, often cross-sectional research, not so much time series stuff in sociology, and ethnographic research, being there and seeing what happens. And beyond this, and again, this is all in the area where I suspect you already know what I'm telling you, what are the typical research design questions that arise in an existing research method? If you want a one-liner about this talk, you could think of it as simulation is just another research method. Let's do all the usual stuff we do when we do a piece of statistical research or a piece of ethnographic research, but let's make sure we do it correctly in the context of a distinctive method. So for a piece of survey research, can I use existing data or do I have to collect my own? Secondary analysis versus data collection. If I'm collecting my own, how do I compare what I'm likely to find out with a national representative random sample, which is what a lot of big government surveys are? Do I have to worry about unrepresentativeness and bias, and how do I deal with that in my data collection strategy? If I'm trying to understand a particular thing, what questions do I use? Do I use the existing questions for educational attainment? Do I need to break them down, for example, to look at people who go to vocational colleges, or should we look at people who get degrees beyond the BA, because most educational research just stops at the BA level because the numbers are so small? Can I come up with better questions to ask what I want to know more precisely? Obviously, gender is a relatively straightforward concept, but educational success could easily be more ramified than it is in a lot of existing research. And if I'm going to do that, though, do I then need to worry about pilot studies? Do I need to do focus groups to get at people's understanding of educational success and so on and so forth, these subsidiary questions? Can I do a more style of analysis? Can I use more high-powered statistics? And if so, can I get the data for that? Generally, the more clever the data analysis method, the more data you need. So you'll recognise all this stuff. Anybody who's ever done statistics, if you're an ethnographer, you'll recognise related questions in ethnography. How do I get access? How do I negotiate my way past gatekeepers? What is my ethical stance? How involved am I in the research? All the usual design questions that would come up that you've all been trained to address from your backgrounds. I'm going to try and present some equivalents to these in the context of simulation research and say, well, what's different, what's the same, what should we think about? A little kind of background thought about this. One of the problems we face with simulation, which is quite interesting, is it may be quite new. And I'm coming to the view increasingly that there's something of a paradox in social science, which is that we're constantly stressing the new. And Bruce talked rather disparagingly of new paradigms. People are always coming up with new paradigms, new conceptual frameworks. But actually, when something is new, our immediate reaction is to say, oh, that's just statistics, or that's just another form of this, or that's just another that. And one of the things I think that's important about simulation is for people to come away with an awareness of just how different it is. It doesn't necessarily mean it's good, or that you need to use it, but to the extent that you think of it as just another something, you tend to lose some of what is valuable about it. And we see that quite interestingly, for example, in economics, where there are fields like computational economics, where they do use simulation, but they only use it in pursuit of pre-existing theory. So instead of using it as a marvellous tool for understanding social complexity, they say, OK, we have this nasty set of equations, we can't solve it by hand, we'll get the computer to do it. And that's quite useful, but they then never ask the question, well, why that set of equations? Why is this system of equations so complicated that we can't solve it ourselves? So by thinking of it as just another tool for solving equations, you're losing quite a lot of what's special about it. And I'll try and illustrate that rather than just telling it to you. But it's worth bearing in mind that this, if we're right, this is something really quite distinctive, and it's not just another one of something else. And that's quite important to doing a good job of it. Partly because you'll need to convince your peers that it's something different and not just another one of. Now, the sins. This is the first sin. The first two are statements of the obvious, I hope. The subsequent sins are a bit more distinctive to simulation. I am surprised at how often this one comes up. First sin is don't have a research question. Say, I'm doing some research on gender, or I'm interested in the police force. If you don't have a research question, how do you know what's relevant? How do you know what previous research is relevant? How do you know what of what you see in a field context is relevant? How do you know what kinds of analysis might be relevant? How do you know that your data or your research methods to collect data are going to give you what you want? And I'm consistently amazed among sociologists, even among professional sociologists, at how many people don't really understand the difference between quantitative research and qualitative research, which in a nutshell is, are you asking a how much question? How much does being a woman affect educational success? Or are you asking a how question? How does racism get propagated in the police force? How are policemen socialised into institutional racism? And that difference is absolutely fundamental between qualitative and quantitative research. And you often see people forgetting it in the middle of their research and trying to tell you about factors explaining this or practices explaining that. So if you don't have a clear research question, you rapidly get bogged down. At the end of your piece of work, if you don't have the research question clearly in mind at all times, how will you be sure you have answered the question? Because this is a very big problem, even with published research, is drift in promise. You start off by promising something and then you deliver something much, much more diluted. And you will all have read papers where somebody says, oh, I'm going to explain social influence. And by the end of it, what they've actually done is shown there's a correlation between gender and something that happened in a lab. Which again is the point that Bruce made this morning. Think about having a one-sentence research question. It's one of these, it is better to travel hopefully than to arrive things. It may be impossible, but if you thought about why you actually can't get your research question into one sentence, you probably will have learned an awful lot about what it is you're trying to do. If you end up having to go to two sentences, it's not the end of the world. You may actually have two research questions, both of which are important, but if you can get it into one sentence, there is no possibility of confusion. There are lots of reasons for this. If you're doing qualitative research, it's really good to be able to tell people in lifts what you're doing, because the chances are by the time you've done half a paragraph, they've got bored and wandered off. Also, if your explanation of what you're up to takes half a page, it may confuse you as well as confusing other people. I've met people who, when you prod them, don't actually know what it is they're researching. They think they do, but it turns out that they've actually got two completely different things going on in their research. Committing this sin often makes the others easier to commit. If you don't quite know what you're doing, it's ever so easy for your research to become fuzzy in other ways. But you knew all this stuff. I'm just reminding you, right? Now, fortunately, Bruce has already shown the Schelling model this morning, so I don't have to show it again. What I'm going to do is make a slightly different point about data. So I will skip the slide explaining the Schelling model. I'll show you the picture. This is the random initialization. This is the famous clustering in pink and white. What's that got to do with good research design? Well, think about what existing research methods, at least in sociology, actually do. And I think, although you might want to disagree with me, that this slide cuts through years of rowing, in sociology at least, about the different research methods. Ethnography looks in detail at neighbourhoods. It looks at individual decision makers, it looks at their context, how they decide when to move, when they're happy in a neighbourhood, and so on and so forth. But it has trouble inferring the cluster patterns. We can know a lot about the way that racism operates in one particular police station without being able to say anything very certain at all about racism in the police, trends, and so on and so forth. Conversely, statistics is at its happiest looking at patterns of clustering, but it has a lot of trouble inferring micro causes from those patterns. It's not to say statistics doesn't often do that, but how solidly anchored those micro explanations are is often problematic. Now, these problems are fully recognised by the research methods themselves. In economics, the problem with statistics is referred to as the micro foundations problem. In ethnography, this is the problem of generalisation or grossing up. I'm not telling you anything new. The new bit comes where we look at how the simulation approach might have something to say about that. And this is the sentence I really like, although it's a bit long, 2 sentences. Going from the macro to the micro and the micro to the macro, the problem is the same in each case. Nonlinearity and emergence, words you will have heard, but I will talk more about, drive a wedge between the 2 levels of description. You can look very clearly at the micro level and see what's going on using ethnographic techniques. You can look very clearly at the macro level using statistical analysis and finding various kinds of patterns. But it's extremely difficult to move from one level to the other using those tools. And the reason why is because what we mean by a complex system. You can't use common sense in grossing up or scaling down, because the whole point about the system is it's not straightforward. It has emergent properties, it is non-linear. So people attempting to start at one end and just drill down or scale up are going to have a problem. And it's a problem within the methods themselves, and it's a problem of something that we're just not very good at doing on a casual basis. Okay, that's the story. I can hear you saying, show me. You've probably heard these questions before. If you're unlucky, you might have heard them from me. You remember about the preferred proportion, the idea of what kind of neighbourhood the agent is happy in. PP is a number between 0 and 1. 0 means they don't care who they've got around them. 1 means they insist that everybody around them is the same kind. What's the smallest PP that will produce clusters? First question. Slightly more tricky one, what happens when the PP is 1? Well, you've probably seen this already. The answer is you only need a PP of about 0.3 to produce respectable looking clusters. And if you have a PP of 1, people are incredibly xenophobic, there are no clusters. Now, both of those results might be seen as a little bit counterintuitive, except among this audience. You've probably heard it 1,000 times before. If I'd shown you this and said, that's Chicago, obviously I would have had to have made it a bit more decorative so that you would believe it was Chicago. As a typical sociologist, you might have gone, oh, well, look at those poor deprived group X being trapped in their ghettos and excluded by the elitist other group. Or if you were a different kind of sociologist, you might have gone, oh, well, that's obviously people liking to get together with people like them. It's ethnic enclaves. That's fair enough. Actually, we know by construction, because we built the model, what is really going on here. Even though these people are all perfectly happy to be in a minority, they have no self-group preference, you get clusters. So if you try to drill down from the pattern to what you thought was going on underneath, you might quite likely have been wrong. It's not to say that all of you wouldn't have got it, because some of you have probably read Gilbert and Troich, but you can see the point. If we'd shown this to people who hadn't already been exposed, they might have read into it various kinds of micro patterns or micro interactions that seemed to them plausible based on common sense. And by construction, we would know that those were incorrect. The slightly trickier one, if I'd said to you, higher PP leads to higher clustering, I suspect a lot of you would have said, well, yeah, that sounds pretty reasonable. People are trying to get away from the other kind. They want to be with more people of their own kind. And yet, when we actually do experiments on this, and of course this is one of the nice things about simulation, that you can do experiments at very low cost, we find that that is absolutely right up to a point. And it seems like a pretty arbitrary point. It's about 71%. So yes, people become more intolerant of the other kind. The clusters get tighter and tighter. They stop sharing boundaries. There tend to be empty sites as buffer zones. Things become more segregated. And then suddenly, at about 71%, boom, the behaviour completely changes. The whole thing falls apart. Now, in retrospect, and everybody becomes very, very unhappy. In retrospect, the explanation for this is pretty straightforward, and I'll give it to you in a minute. But the interesting thing here is that this system is obviously non-linear. No difficulty seeing what we mean by a non-linear system in this context. Over one range it behaves in one way and suddenly it stops and starts behaving in a completely different way. I would have been very surprised if any of you could have read that out from the system beforehand. There might be a few high-powered mathematicians in here, or people who with exceptional out-of-the-box thinking who would have seen this coming, but my guess is that most of you would have done what most statisticians do and say, well, more of the same, more of the same. And that's the way our minds work on the whole. We find it very difficult to do anything else. Now, this is a kind of background thought. As Bruce has pointed out, the real world is a heck of a lot more complicated than the Schelling model. If a system this simple can trip us up, imagine what trouble we're going to have with the real world. Imagine how much more important it could be to have a system that actually allows us to specify process explicitly. Because even with this toy system, everybody decides in the same way, people have the same PP, movement is random, it's about as far away from a real social system as you can get, you still get surprising results. It's pretty interesting. This is what you might call a lower bound style argument, and I think these are quite unusual in social science, but they're nonetheless quite interesting. If we can show something as simple as this if we can show something in a system as simple as this, don't we think it's very likely to be even worse in real social systems? Now, we can have arguments about that, and if people want to do that, that's fine. Chaos theory, for example. People thought chaos theory was fantastic, all these pendulums doing odd things and so on. But actually, it all went a bit quiet when it was discovered that if you added any noise into these systems or you had more coupled elements or whatever, a lot of the really interesting phenomena tended to disappear. They would wash out. So chaos turned out not to be quite such the boom that people originally thought it was going to be. And it could be that these systems behave in this distinctive way because they are so simple. And maybe there are mechanisms in social systems that get rid of these non-linearity problems. But I think if that's so, we need to hear a counter-argument from the people who believe in simplicity. I don't think they can just assert that these non-linearity problems will go away. I think we've provided evidence that there is a problem, and I think people who want to say that there isn't a problem will have to work harder to prove that there isn't a problem. Now, little explanation, just in case any of you haven't thought about this. This also shows us something quite distinctive and valuable about agent-based modelling, which is that it changes the way we look at the world. And of course, Bruce has given examples of that too this morning. And also another thing I like about this from a sociology point of view is that it cuts through an enormous amount of bullshit about one particular sociological theory. Because PP is a minimum, people are always happy inside a cluster. You have no reason to move once you're inside a cluster because you're always happy to be surrounded by people of your own kind. Once a cluster is full, i.e. has no internal vacancies, then it can't be disrupted except at the edges because nobody can move in and upset you. You've got no reason to move out. So this is already a slightly odd way of thinking of these things. We're thinking about the strength of a cluster being its boundaries, not its centre. Its centre is stable, its boundaries are the interesting area. Whether the clusters form or persist thus depends on whether the edges can survive. It's already a slightly intriguing thought. You can't have sharp corners in a cluster because the people out the corners will not be happy, for example. This actually defines properties of the clusters. The clusters can't get too small because if they get too small, their edges get too sharp. So there's an interesting effect about cluster size which comes out of this micro pattern. And we now can immediately understand what happens when PP is 1. Nobody is ever happy at an edge. because they always have some neighbours of the other kind, so they're always on the move, so the edges are constantly boiling away to nothing. That's quite a distinctive way of thinking about this problem. But the really nice thing about this is that in something trivial, an aggregate entity, the cluster, becomes an organising principle for individual behaviour. If there's a bit of a cluster, that starts to affect the behaviour in the context of that initial cluster. So the individuals make the cluster makes the individuals. In this case, it makes them happy. On one sheet of A4, we have got structuration theory, which took Anthony Giddens 3 books to discuss. Now, of course, there's plenty more you can say about structuration, but here in agent-based modelling, we've delivered a lovely, simple example that you can get your head round. And I think that's rather nice and a different way of thinking about the problem into the bargain. Back to data. If we wanted to test this model, and there are all sorts of reasons why we shouldn't, I would argue that actually the best thing we can do with this model, except in certain senses, is to throw it away. You would need 2 kinds of data. You would need individual level data. You'd need to interview people who are moving house. You'd need to observe neighbourhoods and look at what seemed to matter to people. You might want to do experiments about how people decided that neighbourhoods were more or less desirable. People have done things like that. But you'd also need some system level data. You'd need surveys about who lived where. You'd need statistics about clustering. You'd need pattern measures and so on and so forth. So for this model, you would need 2 different sets of data. The 2 sets of data which, generally speaking, never get mixed in sociology, and I suspect probably never get mixed anywhere else either, because I'm not sure you can mix them without something like simulation. So this, in a nutshell, is one of the things that makes simulation distinctive, if you do it as rigorously as possible, and I'll talk about that in the context of the 7 deadly sins later on. You aren't just fitting a model. You aren't just starting with a bunch of aggregate data and trying to find a pattern in it using something like a regression analysis, nor are you just producing systematic description. You're not saying people do this, then they do this, then they do this. What you're doing is combining systematic description with model fitting. You're doing both of those things. And that's really important. And it's often the case that people who come from a statistical background, when they look at these agent-based models, they say, oh, you're just fitting a fiddlier model. No, you shouldn't be. That's actually what you shouldn't be doing, and I'll explain why people often end up doing that. Unless you have the micro-level assumptions grounded in something, you're not really doing proper simulation. You're doing a funny kind of model fitting, and I'll talk a lot more about that later on. But you have to have both of these things in your model in order for it to be a reasonably plausible agent-based model. And of course, Schelling has neither. And as Bruce pointed out this morning, he wasn't intending to. But the model is neither validated nor calibrated. It's not based on a real place. It doesn't attempt to test itself against real data. So it's a toy model. It's a very useful, very interesting, very challenging toy model, but it's a toy model. However, please don't forget my disclaimer. Some of you may be going, what the heck? This is nothing like what I do. I'm quite happy to come back and talk about experiments, about social network analysis, about comparative studies, about archaeology later, but you can sort of see where this argument is going for different kinds of research methods operating at different levels, to capture individual behaviour, which might happen in a lab, for example, or to capture macro behaviour, which might happen according to various statistical tools. I'd be quite interested, actually, if anybody can come up with a research method that already straddles these levels of description in a convincing way. It may be that agent-based modelling isn't the only one that does it. These ideas are captured in the famous Gilbert and Troich box, which I'm sure almost all of you have seen. Just to kind of consolidate what I've been talking about in rather general terms, we start with a target social system. We have to define that carefully. We abstract from it to produce a model. We use the model to produce simulated data. We compare the simulated data with collected data. If it looks something like, and something like is a very interesting phenomenon in its own right, we might make the claim that we have in some sense understood the target social system. This is quite interesting because it is potentially falsification. Your model of the target social system is a large joint hypothesis saying, I think the world is like this. I am prepared to be proved true, to be proved or disproved on the basis of the difference between my simulated output data and real output data. I'm making a testable claim in the same way that they went to look at the wobble of Mercury to see whether Einstein's theory of gravitation was true. That's quite satisfying. You certainly can't do that very much in ethnography. There are questions about whether you're doing that even in statistics, because if you're tuning the model to fit, there's a question about whether you are then independently testing a hypothesis. And even statisticians worry about this. To what extent are you fitting to get fit, and to what extent have you actually proved something that wasn't already known? What? Oh, sorry, I'm very sorry. Gilbert and Troich is the book on social science simulation textbook. It's known as the Gilbert and Troich box. So credit to Nigel, who turned out to be not here, so I could have claimed it as my own, but he might hear about that. So yes, the Gilbert and Troich box. But I won't talk much about that. So second sin, and this is the last statement of the obvious I'm going to make, and I really hope I'm telling you stuff you know already. Those of you who will be doing this for PhDs and postdocs will be up against people who don't like anything new, who don't necessarily like you doing something that they don't do. There are broad-minded people out there. I was lucky enough to have one as my supervisor, but sometimes people just get uncomfortable if you're not doing what they do. If you want to get on well with domain experts, make sure you know what they already know. So make sure that you are already up to speed on the literature before you even start thinking about a model. If you want to back up your research, don't say, I think this is an interesting question. Say, Emeritus Professor Johnson thinks it's an interesting question. He said so in a previous article about epidemiology. There are plenty enough puzzles already identified within the literature for you to take one off the shelf and work with it. When you're rich and famous and emeritus yourself, you can define your own research problems and everyone will pay lots of attention. But in the meantime, when doing something that isn't immediately popular, it's much better to appeal to other people's authority in saying this is a useful thing to be doing. You'll find that even basic stylized facts will weed out many possible models. One of the first things I usually do is produce what's called a version 0 model, which is just something that works. And that's no small challenge. And I find that I immediately have to chuck it out because it produces things like, I don't know, when the price of a product goes down, people start demanding less of it. So, you know, that could just be a bug, or it could be something about the interaction between the various phenomena that I haven't noticed. But it's amazing how quickly even trying to meet the very basic facts in a particular area like social mobility or educational achievement chucks out models, draws attention to things you've forgotten about, throws up bugs and so on and so forth. And I'm kind of fascinated by how often people send me to review models that are simply silly. So I am going to assume a random social network. No social setting has a random social network. The whole point about social networks is that they are not random. So that is not a working assumption for a simulation unless you do a huge amount of justificatory work to explain why that's a good baseline. Because anybody who knows anything about social networks will know that isn't true. So you want to make sure that your model at least touches the baseline of what is known. Question about how far to go and how difficult it is to reconcile all these different views, and sometimes people don't agree, and so on and so forth. But nonetheless, you can throw away a lot of models purely on the basis of a little bit of social science common sense. Of course, the usual reason for doing a literature review, it helps you to refine your research question, and it also ensures that you really are doing something original. There is too much reinventing the wheel in social simulation. I don't really know why. It could be that journals are not tough enough on people who don't do proper literature reviews. It could be that some of the literature is quite hard to get hold of, some of the older simulation literature. It could be that simulation is too new. A lot of the stuff that's out there, some of which is quite good, can only be found with Google. It hasn't reached into the social science publication archives. You often find very good models that are still at the discussion paper stage. You need to know about those. You have to work harder. As Bruce pointed out this morning, if you're going to do simulation. The reason why you have to work harder is actually a positive one, not a negative one. If you're an economist and a statistician, you are only obliged to look at statistical models in economics to develop your model. You can add a couple more variables to an analysis, or you can prove it for the 3-factor case rather than the 2-factor case, or whatever. If you're a modeler and you want to understand, for example, social influence, you're well advised to go and look at the economics models, the psychology models, the anthropology models. You might well want to look at what the qualitative researchers have to say about social influence as well as what the quantitative researchers have to say, which makes you a much better social scientist, because by the end of it you really do know social influence. You don't just know psychology's take on it, or anthropology's take on it, or economics' take on it, but of course it's more work. You plough through more journals, you have to go through more archives, you have to get used to reading journals you don't normally read, written in a language you're not used to. But it's really valuable, because when you've done that, your model really does tell us something about social influence rather than telling us something about psychology or something about statistics. Unfortunately, because we're quite new, you can't assume that the simulation literature contains everything you need to know. There might well be some really good models in whatever area you want to build a model in, but they almost certainly haven't internalised all the literature that you would be advised to know about. As I say, I'm surprised how often, for example, I get asked to review papers on social mobility that don't contain a single piece of sociological research on social mobility. And then we come back to Bruce's point about in what sense is this a model of social mobility if it doesn't know anything about the pre-existing literature. Right, good. Now we're moving on to stuff that you probably won't know, but at least we now know we're all singing from the same hymn sheet. Third sin, don't have clear system boundaries. This is very easy in simulation because it's ever so easy to bung in a few more agents, introduce a new type of behaviour, make the world larger just by sliding a slider. Bruce's point this morning about context, very important. Is my target social system well defined in terms of context? Am I only looking at people at school, or am I trying to muddle that in with people at home, or people in the park, or people in the family context? So a well-defined target system may involve, for example, trying to narrow it down to one particular domain. I'm going to study the behaviour of children in the classroom. I'm going to study the behaviour of children in the family. Because if I'm trying to study the behaviour of children, you're already moving across these contextual boundaries. These sins are linked. If you commit one of them, you are in danger of committing others. If you don't have a well-defined research question, you are much less likely to have a target social system with defensible boundaries. Just seems to be the way it goes. I don't know why it's true, but it's true. Just general confusion sets in, I think. There are tests that you can do. Simulation is still an art, it is not yet completely a science, but there are rules of thumb that you can use. If you want to know whether the boundaries of your system are defensible, ask the question, does it make sense to treat things external to your system as exogenous? So for example, if you can just input rainfall into your model as a time series based on real rainfall, then it's pretty reliable that that is an exogenous variable as far as your system is concerned. Nothing in your system is having a bearing on rainfall. On the other hand, if you're building a climate model which involves things like the level of building, for example, which might actually affect how much rainfall there is, then the rainfall will have to be within your system, and there will have to be some kind of causal link between ground coverage and rainfall. So ask yourself the question, if to define the boundaries of your system, what can I safely put outside? What can I treat as background or noise or simply a time series, something that I don't have to model but can just feed in from outside the system? Often, because people are still finding their way, or just because they like writing code, people try and build a model in an ad hoc way and then motivate it afterwards. That's pretty much guaranteed not to work. The more bits you bolt onto a model, the greater the danger that your target social system will just descend into a kind of a mush. And what I call a theory of everything, where in order to explain one thing, you have to explain everything else in the world. You may all have heard of the story about Borges and his nation of geographers who built bigger and bigger maps. So first they built a map that was 1 to 10 scale, and then they built one that was 1 to 3 scale, and then they built one that was 1 to 1 scale, and of course then they discovered they had nowhere to put it. So in order for a model to actually be any use, it can't be as big as the thing it's supposed to explain. And there are little tricks that you can think about in trying to help with this. Try to make sure that you have finished versions of a model. I am going to go so far and no further. When I've implemented the following model description, I'm going to stop. And that will be my version 0, my version 1, my version 2. If I have a really good idea about what's going to be in the next version of the simulation, I will not put it in the code, I will put it in a notebook for later. And I will label it version 1, version 2, version 3, version 4. Those of you who enjoy programming will find it's ever so tempting just to have a bit of a hack. and the result tends to be spaghetti. There is an art to this. It's a bit like packing a suitcase. You have a certain number of things you want to get in, you put them in one way, you take them out, you put something in another way, and suddenly it all fits. You work on defining the target social system, making a clean definition, you fiddle about, you realise if you conceptualise the problem in a slightly different way, suddenly something that seemed like it ought to be inside the system can safely be treated as outside the system, and you've tidied up the boundary in that area. I'm going to give a worked example at the end of this so that this stuff is brought down to earth. Watch out for committees. Don't let 15 different people from 15 different backgrounds try to advise you on the goals of your model, because again, you will get spaghetti. I'll talk a bit more about how to defend yourself against friendly advice on your simulation model later on, but it can be a bit of a pain, particularly from non-modelers. Here's a visual aid. This is a target social system, a la Gilbert and Troich. A target social system generates lots of different sorts of data. It can generate bar charts, it can generate narratives, it can generate spatial distributions, it can generate various kinds of graphs. When we build our simulation, which is supposed to represent our target social system, we would want to be able to get all these forms of data out of it in the same way, and ideally, if we could manage it, we would like them all to match. So if we could build the magic simulation, the one that really understood the world, and for all the reasons that Bruce raised this morning, that might not be so difficult, the real social system would generate all these different kinds of data, and every time we ran our simulation and tried to generate one of these kinds of data from it, we would get it. And we would think, aha, we have discovered the secret of the universe. That would be what we were aiming at. Of course, we're never going to get there. But this visualization of all the different ways that you can interrogate a system for data and all the ways that you can interrogate a model for data does suggest a couple of additional problems with successful modelling. Sin 4. Do not try to model a system that is too simple. If your target social system is in the business of generating straight lines, you have no excuse for using a simulation. A regression analysis will do you just as well. Now, you might want to disagree with that a bit and say we don't get at cause and blah, blah, blah. But the problem is not actually a problem of interpretation, it's a problem of justification. You can get a straight line out of an agent-based model ever so easily. You've got enough free parameters to play with, you can get it to do anything. The reason we would use a simple statistical model to predict a straight line is not because it's the best explanatory model, but because we don't have enough information in the output data to justify anything more complicated. The reason for building a complicated model is because the output behaviour is itself complicated. And the only way we can justify a model that we believe might work is if it can do a lot of this matching. And a straight line just doesn't give us enough to go on. It doesn't have enough information content. I have seen people, fortunately not many, but some, trying to build hugely complicated models to explain trends. And I just don't see how we justify that. So avoid that. Make sure that whatever it is you want to study is interesting and complicated enough that it's worth starting off on the project. And I'll talk a bit more about that later. So, as I say, Occam's razor, which you may have heard of the KISS principle, keep it simple, stupid, implies an extremely basic statistical model if all you've got is a straight line to predict. There is this idea that sort of lurks about in simulation, which in systems theory is called equifinality. How many models could have generated what we observe? If it's a straight line and the models are very complicated, I strongly suspect the answer is an infinite number of models. I can't prove that. I don't know much good analysis of the problems of equifinality. We all think about it and sometimes we talk about it, but I don't know if anybody's ever managed to say anything concrete about it. I can think of ways of doing that, but I don't think it's been done. So a straight line could have come from an infinite number of models. So fitting a straight line doesn't tell you anything. Not enough information content. This isn't a problem that's distinctive to simulation, except that statistical models seem to be much simpler on the whole. In statistics, it's called overfitting. You've got too many parameters in your model relative to the amount of information content in your data. You haven't found anything out. In machine learning, it's known as the lookup table problem. Have you really learnt something, or have you just generated a long list of every possible case that you can retell? There's a nice example from recognition of tanks. They decided to set up a neural network to recognise tanks. And they started off with a picture of a tank in a field, and they pointed the camera at it, and it said tank on the screen. And they thought, well, that's a good start. And then they put a picture of a tank half hidden behind a tree in the field, and the machine said tank. And they thought, ooh, this is looking better. And then they had one with a tank completely hidden behind a tree, and it said tank. And they thought, oh, something's gone wrong. And it turned out that all the pictures with the tank were taken in the morning, and all the pictures without the tank were taken in the afternoon. And what the computer had learned to do is recognise the pattern on the sky. There's nothing to do with tanks. So this problem doesn't just come up in simulation, it comes up all over the place, but it's worth being particularly aware of it in simulation, because you don't want to try and fit a very simple data with a very complicated model. Here we come back to battening onto the experts. There are plenty of good puzzles in the existing social science literature that the people involved in them know they can't solve. Some of you may have come across the Easterlin paradox. There is a correlation between GDP and self-reported happiness. Pretty sensible. People in richer countries are happier on the whole, on average. But as the GDP of a specific country increases, its happiness does not. There is an apparent inconsistency between the cross-sectional properties of this and the longitudinal properties. Now, it may be that the solution to that problem is trivial. And in fact, I know a lot of people have questioned whether the Easterlin paradox is based on sound statistics in the first place. But that's a nice, simple example of a problem that you might get some purchase from agent-based modelling, and it would be a different way to approach the problem. It is already recognised that that is a problem. There are a lot of papers written on it. You wouldn't have to convince anybody that solving the Easterlin paradox was a good thing to do. Another example from sociology, it has been discovered that relative social mobility, the odds of getting into the top class from different classes of origin, is surprisingly stable. It has been found to be relatively stable in communist countries, in capitalist countries, in rich countries, in poor countries. This is a bit of a surprise. People might believe that different political systems would have an impact on social mobility. People might like to believe that a socialist state would be more meritocratic than a capitalist one, for example. The data does not bear that out. It's a really interesting question why that's true. I don't yet know of any very good explanations. An agent-based account might give us an explanation. And again, you would be knocking against an open door if you built an agent-based model and said, I think I can explain why relative social mobility is more or less independent of political regime. All the social mobility people would at least listen to you, even if they didn't believe your explanation. And that's what you're aiming at, in many cases, as relatively junior researchers. So take someone else's hint about what is interesting, at least at the start. Here's another recap. Another way of looking at the distinctiveness of simulation, just remind yourself of that picture, is that it tries to look at the system and its multiple outcomes, i.e. all that data that you can get out, rather than just correlating outcomes, which is what statistics tends to do, or looking at the system and ignoring the outcomes, as ethnography unfortunately often does. Not quite clear whether it's necessary or not, but it does seem to be very common. I haven't mentioned the issue of parameters. One thing at a time. You may recall in the Schelling model there is this thing called preferred proportion, which is how many people of your own kind you want around you. We might think of this as a kind of a psychological disposition. Some people are pretty laid back and they don't care who their neighbours are. Some people are pretty uptight and they want to be surrounded by people of their own kind. Typically what you think of in modelling, statistical modelling, as well as a parameter, could have different values in different contexts. Inside the simulation, there are going to be a whole bunch of parameters. We would like those to be based on real data. For example, if we were building a model of social networks, it would make quite a lot of sense to have the number of ties in the model to be somewhat similar to the number of ties we find in real social systems. So we have about 5 close friends, 50 acquaintances, and there are about 700 people we've ever met. If we could find a way of calibrating the PP and Schelling, this is how we know it's not a proper model because it proves to be really difficult to do that, we could say that the model wasn't just a toy model, but potentially was starting to produce output data that we could test, telling something about the social world. However, it's often really hard to achieve this. It would be lovely if we could build our model, slot in all the data that we needed about the parameters and go and discover that this thing matched the real data very well. Some things just aren't known. For example, it's extremely difficult to get large-scale network data because of the way that network data is collected. Unless you can get 95% response rates, which is extremely difficult with the general population, you get disastrous, non-normal problems with the structure of the network. There are ethical issues about very large-scale networks, and so on and so on. So if we want to slot a very large-scale social network into a simulation, we cannot just draw on an existing data set. There simply isn't one. There may be one at some point. We may be able to infer things from smaller-scale network data, but at the moment we're stuck. Or, and this is particularly for the PhD students in the audience, you don't have time to measure it yourself. You can clearly define what knowledge is needed. It's the normal sort of knowledge that social scientists are quite capable of collecting, but you've only got 3 years. So, for example, you might have a psychological value in your simulation. You can see perfectly well how it might be measured by an experiment, but you've only got 3 years, and you're going to have to hope somebody else does that experiment at some point, and then you can put it in your model. So there is always going to be a certain amount of fudging in your parameters. No matter how hard we try, there's always going to be stuff we don't know, stuff we can't get yet. Stuff that's just not very accurate. You know, the best guess about close number of friends is 5, but plus or minus 3 or so. That's actually a pretty broad band on 5. So there's always going to be a certain amount of jiggery-pokery when you're building your model. Which takes us to the 5th sin, trying to model a system that's too complicated. If you have a nice rich simulation, you can get lots of different kinds of output from it, and that increases your confidence that you really have understood the system and it isn't just a lucky fluke. But that's no good if in order to build that model you've had to stuff it full of fiddle factors, parameters that you have no idea how to calibrate. Or even worse, have such a broad range of values that you can get any behaviour out of the system. So there's a trade-off between having a nice big model, which is very convincing in the sense that it produces lots of output data you can check, and having too many ungrounded parameters in the model. There's a very nice example of a model by Torsten Hagerstrand of spatial diffusion of innovations from 1965, where he has basically one parameter, which is estimated indirectly from information about migration and telephone calls, and his model fits very well. And you can trust his parameter value pretty precisely. So you don't need to have a huge number of parameters, but if you are going to have a large number of parameters, make sure you can actually fit them to something. Otherwise, you've basically blown up your model. And it turns into a kind of ugly statistical fitting because you're just tweaking the parameters to get fit. The Anasazi model does a bit of this, the very famous Santa Fe one. There's an awful lot of tweaking going on to get that line of best fit, and even that line of best fit isn't particularly good. You can make this a design principle, and here we're back to the art of simulation. Every time you add a parameter to the model, ask yourself, can I measure this? If I can't get data now, can I see how it could be measured? Some parameters are much less harmful than others. A measure of close friends sits quite nicely with social network analysis data. A psychological notion of cognitive dissonance, not so easy to measure. See if you can do without it. This is still scientific, don't be defensive. One of the things about learning to be a simulator is to know when to fight back when people accuse you of various methodological weaknesses. If you can say how something can be measured, and it can be measured using existing social science methods, the fact you haven't measured it, it's still scientific. It's only if you've invented some peculiar concept like phlogiston or whatever that you've gone outside the realm of science. So it's perfectly okay to say, my model needs this bit of data, it would be collected this way, but I don't have it. And that's a perfectly respectable model. And it's also a good exercise for you in model design to think, well, why did I put that parameter in? Why is it so difficult to measure? Could I break it down into something a bit more intuitive? Here's an informal definition of elegance. Agent-based modelling, like mathematics, relies to some extent on elegance. The things the model will explain proliferate faster than the parameters you put into it. If you put enough parameters into a model, you can get it to do almost anything. The really elegant ones are the ones that manage to cover a wide range of interesting behaviours using a relatively small number of parameters. And as you go, you will find that you have to add parameters to a model, but try not to add them too fast relative to what the model will actually do for you. And again, back to Bruce's point this morning, if you make the model too complicated, you may never understand it, whatever you do with it. And obviously that's not a winning situation. This lurking idea of equifinality, how many different models could have produced the same outputs? It seems reasonable that the more outputs you can match, the greater the likelihood that your model is in some sense true. That seems reasonable, but we don't know if it is true. Even worse, I'm not sure we know how to decide whether it is true. So it is something of an article of faith, but it does seem like a reasonable article of faith. If you can track 5 different sets of data from your model relative to one set of data, it's more likely to be hitting the truth, as long as you watch out for this too simple, too complex issue that I have outlined. The other thing, though, to think about here is where the burden of proof lies. There's more to science than simply following one's methods. Sometimes it's about the way that academic argumentation proceeds. So, for example, people will often say to you, oh yeah, well, your model's no good because it doesn't contain power relations, gender, network structures, blah, blah, blah. What you say is you smile very sweetly and you say, could you give me the evidence that these things matter? And they often will not be able to do so. What evidence do we have for rational choice being a good model of decision making? It's an interesting question. So, not saying you shouldn't listen to people, but there is a burden of proof on people who suggest that you should add things to your model, and don't forget they won't be doing the programming, so it's very easy for them to suggest this, that they have some good reason to think, some evidence-based reason to think that it will make a difference. Not just that they quite happen to fancy their particular research topic being in your model. I'm sure there are lots of models that do that, a kind of equifinality argument. Okay, then you build me another one that's completely different. Put the burden of proof back on them. Don't just say, oh, well, they have to do some work too. Other ones that you sometimes come across, that isn't interesting. Well, I'm sorry you are so hard to please. That isn't sociology. Oh, do you get to decide? So you will get criticised if you do this. It is new, it is different. Yeah. Think about where the burden of proof lies. Think what you have demonstrated and what somebody criticising you should be obliged to demonstrate. And you will feel calmer and happier if you do this. But people have these hidden beliefs about how things work, and their hidden beliefs are no better than your hidden beliefs. And you need to bear that in mind. Sin 6, careless choice of domain. Bruce's comment about hammers and nails, slightly misquoted, but that's another story. There is still plenty of room to build the first simulation in a particular area, which is really nice. You could really be the first one building a simulation of some kind of criminal behaviour or certain kinds of educational behaviour. But if you're going to start out on this, if you haven't done it before, don't start in a data poor area. Don't start somewhere where nobody knows anything. And don't start in an area that's otherwise tricky. I know we've got an archaeologist here. Ancient history is a real problem because it isn't just the case that simulation doesn't know what parameters to put in its model. It's not clear anyone else knows either. We can't interview the people. The traces they've left behind are themselves subject to negotiation and interpretation. It's not saying we shouldn't try modelling ancient historical processes, but it's probably about as difficult as it will ever get. And the only reason you might try it is because all the other methods are probably even less effective. So unless you have to, because you're an archaeologist, for example, don't start there. Don't start in areas which are totally dominated by any one group of researchers. Don't start in an area completely dominated by statisticians, because they will expect you to translate your model into some sort of statistics. If you do things that are only ever been done by ethnographers, they probably won't even understand you. So try and go into a research area where there are at least some people doing a bit of each, so that you have your micro level and your macro level data that you can get at. And you can flout all these rules later. Once you've got the hang of it and you know what you're doing and you're confident and you've got your PhD or whatever it is, by all means go against these rules. But for now, it's worth bearing them in mind. Stay out of extremely novel fields, because nobody else knows what's going on either. Try and avoid domains which have left social science. Don't have anything to do with postmodernists, for example, because There's just no point, really. There's nothing to talk to them about. So pick a good solid area where there's lots of data of different kinds, where there is disagreement, where there are recognised problems. Don't accidentally pick an area which is just a wasteland where nobody knows anything, nobody's sure about anything. And this is no different from any other research skill. If you were an ethnographer and you suddenly decided you wanted to be a statistician, you wouldn't start by building a government-grade econometric model. You'd kick off by running a few regressions on a data set that you downloaded from the ESRC data archive. And if you wanted to be an ethnographer and you'd previously been a statistician, you probably wouldn't start with an ethnography of serial killers in a maximum security prison, because it might be a bit tricky. So try and start with something that's not too difficult, and try to be aware of the kinds of things that makes this kind of research particularly difficult. And one of the things that makes this research particularly difficult is no data, not surprisingly. Sin 7, doing too much at once. What you're partly doing here, try to split the technical skills from the intellectual ones. It's one thing to build a model, it's another thing to think like a simulator, to see what are good topics for simulation, to come up with a good research idea that is simulation based in the same way that you come up with a good statistical research idea or a good ethnographic research idea. Some people get one skill before the other. I think the second one is probably harder to get. Being an expert statistician or an expert ethnographer is a kind of mysterious process coming out of lots of direct experience of doing ethnography. Same with modelling. You develop a kind of intuition about what works and what doesn't, but the only way you develop that intuition is by trying it in lots of different contexts. Read lots of simulation. Again, I'm afraid that might be a statement of the obvious, but don't just read it in your area. Sometimes somebody's got a really neat model that will do for what you're doing, but not necessarily already in your field, because this is still a bit amorphous. JAS, Journal of Artificial Sciences and Social Simulation, is free and online. You can get lots of pretty good stuff just off the web. You might decide that actually the first thing you want to do is a replication. Those of you who want to do a self-contained project or are allowed to do a PhD that consists of separate publications might want to take an existing model in your area and just do it again in a different programming language. If you do that, you've pretty much removed the intellectual challenge, although I can pretty much guarantee you'll find out some interesting stuff, but you're giving your technical skills a good workout. So don't necessarily assume that to kick off in this area you have to start with a marvellous, all singing, all dancing, brilliantly unique idea about simulation. There are plenty of useful things you can do before you get to that point. And as I say, what I often talk about is a version 0 model, a simulation model that works and doesn't do anything stupid. And there are still areas where a version 0 model is still better than what we already have. Just something that behaves broadly, sensibly and then can be developed in more effective ways can still have publishable value because simulation is so new. Sorry, this is sin 8. Shouldn't really be 8 deadly sins, but I forgot this one. If you are in a field where there are already models, please don't ignore them. One of the problems we have within simulation is what I call the piles of models problem. People in the iterated prisoner's dilemma go, oh yeah, I could build a model of the prisoner's dilemma. I'll take this idea from here and this from this article I once read and this and this and this. And you end up with a model that can't be compared with any other model. It produces some results. Maybe you get cooperation, maybe you get defection. And there is no progress in the field. You just get this heap of models. So again, if you want to get your feet wet before you start, think about whether you might want to try and develop something like a test bed that would allow you to integrate 2 or 3 good prisoner's dilemma papers and show, for example, whether the results you get without networks are affected by adding network structure to the model. And that would be a nice, safe thing to do. You don't have to be a creative genius to come up with that idea, but you are doing something that contributes to the literature and actually goes beyond what a lot of prisoner's dilemma models manage, which is to be comparable with other models. And what you find here, actually, ironically, is that simulation ends up rather like statistics, what you might call a variable zoo. People go, oh yeah, I'm going to build an IPD model which has learning and networks and memory and types. And then someone else comes along and goes, well, I'm going to build one that doesn't have networks, but does have types and memory, but also has learning. And then what do we conclude? I mean, it's a bit like statistical models. Well, I'm going to put gender in, I'm not going to put gender in, but I'm going to put ethnicity in. And they fit about as well as each other. So now where are we? So think carefully about fitting what you do into what has already been done, if there are models out there already. Now, I'm going to wrap up pretty quickly. This is an example. I realise all this has been at a very abstract level. Here's something I'm doing at the moment with a PhD student. The reason I'm telling you about this is because she's in the situation that many of you are in. She doesn't particularly want to be a modeller, but she's come up with some very interesting data, and it seems a shame to waste it. There is a theory called Rambo's stage theory of religious conversion that says that people go through about 7 stages when they convert from atheism to one religion or from one religion to another. But the theory is not very brave about the order in which those stages occur, or even whether all the stages need to occur. It's quite a cautious theory. They just say there are these stages. So our research question is, how do we explain stage order in religious conversion? So we're taking Rambo's theory, which is pretty well established, and adding something to it. Can we explain the stage order rather than just say there are some stages? What data exists? Well, as your PhD of doing this, we find a number of case studies, people converting to Buddhism in South Africa, people converting to Islam in Denmark, people converting to Islam in the UK, and we find one quantitative attempt to measure stages in the US, a paper by Khan and Green. So we haven't got a huge literature to struggle with here, but we know what it is. Asia has done ethnographic work on the Dusun tribe in Brunei converting to Islam, which is the state religion. What's interesting about Brunei and why we picked it is that because Brunei is a state religion, whereas America doesn't have a state religion, the people who are converting, the Dusun, are converting from what you might call a non-world religion. It's not Islam, Buddhism, Christianity. It's a traditional animistic religion which is local just to that region. There's also been a gender shift. The priests, well, I don't know what the correct gender-neutral terminology would be in this case. The people in charge of the Dusun traditional religion are women. The people in charge of the Islamic religion are men. So there's been an interesting gender shift from a female-dominated religion to male-dominated. So it's an interesting case study for all sorts of reasons. But what we do find, and what started me thinking about modelling, is this process gap. Azzy is telling me all sorts of interesting things about the conversion process, but we don't know how it unfolds in a systematic way. So I'm thinking, aha, modelling. And she's done a certain amount of ground clearing. Rambo's model is a bit messy. So, for example, there's something called a context stage, which turns out not to be a stage at all. And things like, what do we mean by an encounter? There's supposed to be an encounter stage, and Rambo was imagining someone coming and knocking at your door and saying, hello, I'm a Jehovah's Witness, do you want to convert to my religion? That isn't always how people's experience of conversion happens. The key person could be a family member, they could be a teacher at school, particularly in a country with a state religion. And one of the other things we've been unpicking empirically is to what extent does Rambo's model depend on hidden assumptions about the way that US Protestantism works. So to what extent is this a culturally specific theory, try to generalise it so that we retain the stages, but we get rid of the American scaffolding. We end up with a description question. Why is a particular stage pattern common in Brunei? How much variation is there in the stages? How clean is this data? So, of course, I'm already thinking in terms of an agent-based model. Agents are at different points in the conversion sequence. They're interacting with the environment. For example, they're receiving lessons on Islam at school. It's very interesting. It's great stuff, ethnography. Religious classes are not compulsory in Brunei, but a lot of the Dusun children attend them. They don't have to, but they go to these classes on Islam, even though they don't want to convert and their parents don't want to go to convert, but they still go to the classes because they want to be with their friends. And as a result, they pick up lots of information about Islam. So if they ever decide they do want to convert, Islam tends to be the religion that they convert to. So there's all sorts of interesting detail that you can get out of ethnography that you wouldn't get if you just tried to dream up a model in an armchair. The other nice thing about building these agent-based models based on real data is that they usually open up really good general questions. And the perfect research project is one that answers a specific question but also gives a light onto a general question. Those of you who are starting out in research, something that can then give shape to your research career. So I've done a case study of a particular thing, but here is a bigger issue that this taps into. And in this case, part of a very interesting general question is, what is a stage theory? Why do we have theories about things proceeding in stages? And we can think of logical explanations. For example, you can't make a choice between options until you've identified a set of options to choose. That's kind of a logical stage. We can also think about other kinds of stages that might exist. So the question is, why are there stages in conversion? What does that mean? So that's the background. Here's the model. Abstraction is one of the most difficult things to explain in simulation. I can only demonstrate it. The first stage in conversion, according to Rambo, is a crisis. you suddenly realise that your religion or your lack of religion does not help you in your current life situation. Now, this is ridiculous, but let's see how far we can go with it. We will represent your life situation as a binary list of ones and zeros. You have children, you don't have children, you are sick, you are well, you like your job, you don't like your job, you like your wife, you don't like your wife, etc., etc., etc. Now, this is clearly a radical abstraction, but this is version 0. We're going to see if it works. And you have a belief system, and your belief system can match or not match your life situation. So, for example, you have a child and the child dies, and your religion does or does not comfort you about the fact that you have lost a child. And obviously, if your religion doesn't comfort you about the fact you've lost a child, you are quite likely to think of other religions or possibly to move away from a religion that hasn't helped you in that extreme situation. So obviously, your life situation can change, and that's exogenous as far as our model's concerned. Remember, we're talking about defining the scope of the system. We're not going to model when people decide to have children, whose children get sick. We're just going to assume all those things happen in probabilities according to the data. This may lead you to a crisis. My religion no longer fits my life situation. Then we move on to a question about how people acquire knowledge about these religious belief systems. And the Brunei case is very interesting. If I asked you how much you knew, for example, about Buddhism, I would suspect that the Buddhists would know quite a lot, and that a lot of you would have some background knowledge about what Buddhism believes, some of which might be wrong. But we can see how these agents might potentially be acquiring new bits of belief about particular religions, which would then allow them to compare, for example, one religion with another. Now, this is extremely abstract because, as Bruce pointed out this morning, it's non-semantic. We're not looking at the way that people interpret religions to make sense of the world. We're just assuming that they can match up these lists. But remember, this is just the first version. So if I meet somebody from a particular religion, obviously the first thing I learn about the religion is that there is such a thing as that religion. So the first time I meet a Buddhist and say, well, you know, what do you believe? And say, well, I'm a Buddhist. And I think, there's a religion, Buddhism. But in the case of Brunei, for example, there's a lot of broadcast information. A lot of information about Islam in the first instance comes from the television. They have compulsory religious broadcasting in Brunei. So a lot of people who have no interest in Islam know a lot about it, and they know a lot about it at school. But that obviously has an effect on what happens to them if they ever have a crisis in their lives. Because if you like, they're pre-cued to examine a particular religion, and they may find it unacceptable, but at least it's there for them to consider as a first guess. So again, we're treating a lot of this stuff as exogenous. We're not trying to explain why it is that Brunei has religious broadcasting. We're just taking it for granted that they do and looking at the effect it has. Good thing about building a model is it tells you what you don't know. We don't know, for example, how many belief systems people keep on the go at once. Are you all collecting background information about Buddhism, Christianity, being a Jehovah's Witness? Or are you collecting no background information because you're just not interested? Or are you perhaps collecting more information about a religion you happen to be regularly exposed to? Like a lot of your family are Catholic, so you tend to acquire more background Catholic information. Or perhaps if you're experiencing personal crisis, you're in information collection mode and you're collecting everything that's going because you know that at some point you'll want to compare your own lifestyle with another religion. This raises another interesting general research question about dynamic choice. We all know the rational choice idea. You get all your options, you line them up, you look at which one you prefer. What happens in a dynamic context? If I have a crisis, that may be what triggers my choice, my comparison. I may recompare every time I get a new piece of information. That's another interesting, different kind of choice mechanism. I may reject something before I have a complete set of information because what I know about it is already so unpalatable. So, for example, I could not possibly believe in a religion that opposed abortion, for example, because that goes against my principles. So there are a whole lot of interesting things that could be happening when people are acquiring information piece by piece on different choices, which leads to a whole general class of models worthy of study. And this has arisen from one particular case study of a particular phenomenon. So there's a lot here from my one piece of ethnography, and it wasn't even my ethnography. Another area of ignorance, there's an encounter stage. You meet someone important to you. What does the encounter actually do? Well, we can have a number of sensible hypotheses. One thing an encounter might do is give you lots of information very rapidly. A man standing on your doorstep might be able to fill you in on all the details about what Jehovah's Witnesses believe in about 10 minutes because he's trained to do that. Or it may be his job to persuade you not to provide you with any information about what Jehovah's Witnesses do, but to encourage you to think seriously about what it might be to be a Jehovah's Witness. Or, and this is what came out in the Brunei case, you might look at a Jehovah's Witness and say, they seem like a happy person. Maybe I should think about emulating the religion that they have. And there could be other things that an encounter does, but we don't know from the data. But the model is setting us up to have a clear understanding of the kinds of things that the encounter process might do. I'm going to wrap up quite soon, you'll be pleased to hear. One of the interesting things that you find yourself doing, and again, this is something I can only sort of describe to you as an art rather than you can't formalise it as a science, is that moment in building a simulation where you suddenly step back from the part of the model you're working on and recognise a broader unifying principle. So I've been thinking in this model, because I've been thinking in terms of these naive lists, I've been thinking in a sort of cost-benefit way. You know, I like the incense, I don't like the big crowded churches. I like the praying, I don't like the having to fast. It's this sort of rational choicey notion of religion. But a sudden step back, coming from the data, family are payoffs too. If I convert to Islam and my mother is going to sulk for the rest of my life, that's a big negative payoff. Now, of course, it isn't necessarily how we want to represent family relations as rational choice, but it does draw our attention to the fact that part of the cost of conversion is a social cost. And that's a sort of a unifying moment where I can think of these two very different phenomena, family reaction and personal choice and religion, as part of the same framework. Now, it may not work, it may turn out to be too naive or too simplistic, but I'm going to go with it for now. And we do have real data about, for example, long postponed conversion. People have put off converting until their parents die, for example. And there's another example of this stepping back approach. A lot of stuff coming up about social networks, who people got advice from, whose lifestyles they emulated, how they developed a more positive view of Islam as a result of seeing the people who'd already converted. A more general social process that networks of approval and disapproval may or may not sustain conversion. So you might join a church and get lots of great new friends. You might join a church because actually you've never liked your family very much anyway and you're not losing much. So there's an important general question about how, when you make a social change, the tension in your network reconfigures itself. Are you getting enough compensation from the new contacts you're making to compensate for whatever you're losing? And obviously some people are never going to move. Some people are going to be so attached to their families who are violently opposed to conversion that they will never convert. And other people are going to convert incredibly readily because there's actually nothing keeping them in their existing social circle. And once we've thought of it in this terms of sort of balance, we start to find elements of that in the data, and hopefully we're not just reading them in. This leads to further research. You know, we started with one ethnography. We've already got two really interesting general research questions going here. We'd like to look at the people who abandon their conversion process. Where do they give up? Why do they give up? We only look at the people who followed it through to the end. Family conversion is very important in Brunei. Does it follow a different process from individual conversion? Actually, a really interesting question for America too. What happens if your dad converts? As far as we've been able to tell, nobody really knows. You would expect it to have an effect if you were 6. Does it still have an effect if you're 16, or do you just allowed to do your own thing? To what extent do parents make the children responsible for their conversion decisions? And at what age do you get treated as an independent person who doesn't just have to go along with a family? So again, lots of stuff thrown out by this new way of thinking about things. I'm just going to kind of quickly go through the sins and then I'll stop. The model inputs here are going to end up being things like the level of media coverage, people's attitudes to the religions as established by surveys, how many people are converting over time, how likely the networks are to be homophilous. So to what extent do Muslims only know other Muslims and Dusuns only know other Dusuns? Now, of course, some of this data is available, some of it we can see how to collect. We haven't got it all yet, but none of it looks to be fiercely difficult to get hold of. And the outputs are conversion sequences. Why do we observe 80% of people converting in this particular context to convert in this order rather than some other order? The nice thing about this is we can start to get some notion of system complexity. We've got a theory with 7 stages and we can allow for blanks, so some stages can be missed out. This gives us sort of, and some of you can spot why it's only sort of, 7 to the power 7 possibilities per agent. 7 to the 7 different sequences that could occur for every agent, roughly. How many of those do we actually observe? How powerful is this theory? If we can only predict half the possible sequences, not very strong. If we're predicting one sequence out of 7 to the 7, really strong. So how well are we doing in terms of the possible states? And this is slightly unusual in the simulation because here the possible states in some sense are quite clearly defined. We might think, if we're predicting a very small subset of possibilities, that it's unlikely that this is just a fluke, that this is just a side effect of equifinality. We can also think about what data we can hold back to test the model. For example, time to conversion, how long it takes people to convert as opposed to the stages they go through. Because, as I said, we always have to guess some parameter values. You can almost never get away from it, certainly for version 0. If we can get plausible time to conversion patterns, that gives us some independent evidence that our guessing hasn't made the model too silly. And then finally, this gives rise to a significant research program. We'd like to do surveys in different countries about conversion stages, how much variation is there across country, which country should we study next, how do we contact bailouts, what is actually going on in encounters. So there's a whole bunch of questions coming out from the model and the ethnography taken together. Okay, final thought. Not really a conclusion, just a final thought. Statistics looks at regularities in variables. Ethnography looks at regularities in practices, ways of doing things. Does simulation look at regularities in process? Here I've been describing a model of a conversion process and saying that things have a tendency to happen in a certain order depending on the nature of the religious context. Now, unfortunately, different social science methods have their own views about where social regularity resides. If you ask a statistician, they'll say that variables are the place to find pattern, robust scientific pattern. If you ask an ethnographer, they'll say we're looking at regularities in practice. We're not looking at patterns in variables. Simulation might say, well, we're interested in regularities in process. Can we stop these beliefs about where irregularity resides being merely religious? I believe this, you believe that. There's nothing more we can say about any of this stuff. Can we offer sort of on-the-tin instructions for the use of methods? That's sort of what I've been trying to do. Say, can we independently of what we want to model, say sensible things about when simulation should be used, which don't beg too many questions, don't jump to too many conclusions, and go beyond saying, I like statistics, I like ethnography, I like agent-based modelling. And I hope I've tried to open up some of the areas where we might make those comparisons. Whether I've succeeded, I'll kind of leave up to you. What we don't want to do is use the criteria of the method itself to decide whether it worked or not, because amazingly, methods very rarely come to the conclusion that they don't work. Catch a statistician going, that model's got lousy fit, I'm going to go and become an ethnographer. The basic faith remains that statistics is the solution. If I just keep cracking on long enough, I will get a model that fits. Similarly, if I carry on being an ethnographer long enough, I will understand what's going on. There's no point in me ever doing a survey. And I worry that that is not the right approach. And I think simulation can start to help us talk about how some of the other methods could justify or not justify their approaches. Thank you all very much. There's a little bit of time for questions. I'm sorry, I went on longer than I expected to. I shouldn't have added the example, but I hope you found it useful. Stunned silence.